Hello, thermal people. Today we're going to talk about the difference between a real Rankine cycle and an ideal Rankine cycle. Ideal versus real. We need to know that they exist and what the difference is. When we talk about cycle analysis, I will ask you the difference between ideal and real. So put a little star there. This is true for any kind of cycle, whether it's an air conditioning and refrigeration cycle or if it's a Rankine cycle. Now, the biggest difference between an ideal cycle and a real cycle is that there is friction in the work processes. Friction means that entropy goes up. We saw that when we were dealing with the expansion valve in a refrigeration cycle. The friction caused the entropy to go up. So let me quick draw a real Rankine or an ideal Rankine. I can do that right here. Whoa. And then next to it I'll draw a real Rankine. Whoa. Put in a low pressure of the condenser. High pressure. And we will call this one ideal. This is in core thermal up until this point. It's all we've talked about. And we showed the work being a straight line down and said that entropy 2 was equal to entropy 1. And we did the same thing going up, and we didn't worry about the entropy over there. So what's different for a real cycle? Well, in the turbine and the pump, those are the work processes, the friction goes up. This is the difference. Not the friction goes up, there is friction, so that causes the entropy to go up. So if I start right here, straight below that would be the ideal point, but we are not in an ideal, we are in a real, so the point 2 actually moves over to the right. We call this point 2 ideal, that's just like this one over here, we call this 2 real. So point 2 real, S2 real is greater than S1. S2 real is greater than S1, and the same is true from 3 to 4. S4 real is greater than S3. That's it. Now there is the downfall to this is we used to find the ideal point nice and easily using steam tables and the same entropy. And we found ideal 4 ideal. We found that using the pressures and specific volumes, and there's a whole video on how to find H4. Here's the problem. H2 real and H4 real aren't the same as H2 ideal. So there's one more step in the process. And we use what's called the efficiency of the turbine and the efficiency of the pump. Efficiency of the turbine, efficiency of the pump to find H2 real and H4 real. But this is a skill that we use in an advanced Rankine cycle. Don't need to do it here, just need to know that it exists. So what's the takeaway from this video? The difference between a real and ideal cycle is friction in the pump and in the turbine. That friction causes the entropies to go up. There's a process using mechanical efficiency of the turbine and the pump to find the new H's. And that's it.